I'm going to talk about solving radical equations. Now, a big idea with respect to solving radical equations is you want to isolate radicals on one side of an equation. And then you raise both sides of the equation to the necessary power to eliminate radicals. Okay? Let me repeat that. You want to isolate radicals and then raise both sides of equations to the necessary powers to eliminate radicals. Okay? So let me show you an example of what I mean. Suppose you wanted to solve this equation. Okay, so let's isolate the radical by adding 5 to both sides. Now let's square both sides. Okay, and look at that. There we got our solution. Okay, this works with more than just square roots. Suppose we wanted to solve this radical equation. Okay, once again, I isolate the radical. And now I raise both sides to the necessary power. In this case, I'll raise both sides to the 5th power. Okay, and so x is equal to 31, which can be found by subtracting 1 from both sides. And if you plug that into the original equation, you'll see that indeed it satisfies it. Okay? Now, the same procedure works for equations that involve fractional exponents, because fractional exponents correspond to, or expressions with fractional exponents correspond to radicals, right? Expressions with radicals. So let's solve the following equation. Okay, x to the 1/3 minus 2 equals 0. So isolate the expression with a fractional exponent. Now raise both sides to the 3rd power. And you see you get your answer in a similar manner. Okay? Now, in addition to isolating radicals and raising both sides of equations to necessary powers, you also have to remember to plug in candidate solutions into the original equations. The reason is because this method will sometimes give you candidate solutions that are not legitimate solutions. Okay, so let me repeat that. You need to check every candidate solution to make sure it's a legitimate solution. Okay? Here's what I'm talking about. Suppose you wanted to solve this radical equation. Okay, so using what I just suggested, you would isolate the radical on one side of the equation. You could subtract 4 from both sides to do it in this case. Now you could square both sides. And so x minus 4 squared, you can work that out if it's not clear that that's equal to x squared minus 8x plus 16. Now we subtract x and subtract 2 from both sides of the equation. And so that gives x squared minus 9x plus 14 equals 0. Now we could factor that. Okay, so apparently the two solutions are x equals 7 or x equal to 2. Now do me a favor. Would you plug in 7 and 2 into the original equation? If you plug in 7, you will see that the left side gives 7 and the right side gives 7. Okay, so far so good. But if you plug in 2, you will see that the left side gives 4 plus 2, which is 6, and the right side gives 2. So 2 is not a legitimate solution. You see what I'm getting at? So the only solution for this problem is 7. Okay, so please remember to check the candidate solutions. Now, let's have you do a problem. Would you please solve this equation? Okay, so pause the video and do that now, please. All right, I'll go ahead and solve it as well. I'll move the radical to the other side first by adding the square root of x plus 6 to both sides. Now I'll square both sides of the equation. Okay, and so continuing and then factoring. Okay, so the candidate solutions are x equal to 3 or x equal to minus 2. And if you plug in minus 2, you will see that it does not satisfy the original equation. So I hope that you remembered what I said and you discarded that candidate solution. So I hope your only solution was the 3, which is correct.